SAMM is a great model, and one of its strongest suits is the fact that it is open source and community driven. To build on this, we are in the process of launching a podcast to bring the SAMM core team even closer to the community. The podcast will bring real world insights, practical implementation stories, tips and tricks from the industry and SAM's ecosystem. Now, unfortunately, creating a podcast is not just about bringing a host and a guest and making them chat. It requires quite some preparation and planning. While we are still working very hard on that, we thought, hey, why don't we just try all of that out in a more informal setting during the community calls? And here we are with the first edition of the podcast, or maybe shall I call it podcast mini. The first topic we have chosen is architecture assessment, which is architecture validation and architecture mitigation. In our opinion, it is perhaps one of the least well understood practices in the SAMM model. This is why we have selected it. Note that the topic might feel somewhat advanced, especially if you are just starting your SAMM journey, but we hope that you will get back to this mini podcast after whenever you're ready for it.
Well, SAMM Podcast, today the topic is on architecture assessment. So it's indeed, as Adam said, a topic that can raise quite some questions. So because of that, we've invited two of our team specialists on this matter. That's Brian Glass from US and Bart de Win here from Belgium. And we've prepared a couple of questions on the topic of architecture assessment, just to be sure that we're all on the same page. The SAMM model, we have about 15 practices, and as part of the verification business function, we have architecture assessments with two streams: architecture validation, and then which is stream A, and then stream B is architecture mitigation. And that's really the first question that I have for you both. Imagine that you're explaining this to a junior developer, so with no prior knowledge on this. So what really is architecture validation and what is architecture mitigation? What's the difference there? What does it mean to validate an architecture? And what does it mean to actually mitigate threats at the architectural level? Because that seemed to be like the two streams here. Any insights there that you can share?
Brian, you want to kick it off? Or
Sure.
shall I? Yeah.
No, this is one of the, and I like that Aram went in with all guns blazing for this part of SAM, because this is probably one of the more debated areas within SAM in terms of interpretations on what we think of it and how we interpret it. So from my perspective, in my interpretation of how we're doing this or how we look at it and how I translate it for people, is architecture validation is going back post implementation, right? So we have threat modeling that in theory should be pre-implementation, pre-coding. Architecture validation is saying, hey, we said we are going to design it this way. We said we needed these security controls. We, in theory, created all of this. Now we want to go back and look and say, hey, was it good, right? Was the design good? Did we appropriately put the right controls in the right place? But we're not talking about the implementation, right? Whether or not we coded it well to the requirements, but were the requirements we thought that were the right things for security controls actually the right things? And sometimes it may take months or a year before you go back and revisit this. This is not necessarily in that one cycle, that one project cycle. But this is, hey, because we run into this problem with long-lived applications a lot of times where you design it once and then it kind of organically grows and nobody ever goes back and looks at it carefully to say, hey, is this still doing the right thing we need to do? And sometimes that comes down to we're forced to because somebody said, oh, you're going to do single sign-on now, or you're going to integrate with this access control model, or things externally change that force you to go back and revisit. For me, architecture validation is you going back and revisiting that design. Like, do I have the right controls in the right place for things that shift? in terms of things change over time, technologies change. Is there a new or better way to do this? And then architecture mitigation is more looking at external forces that change. So it's more like, I mean, very shorthand, it's to me, it's more like threat intelligence. You know, am I looking at what kinds of threat agents, what kinds of risks that are outside of my application that may change? Am I adequately designed to be able to handle this? And so it may be that at the time of the design and creation of this application, denial of service via botnets was not a problem. We never designed with that particular threat in mind. Over the last couple of years, that type of threat, and this is just an example, there's a whole bunch of them you could pick from, that type of threat reared its ugly head and is now a major problem. Am I making enough changes to keep my application in line or up to date with what's changing around it from the outside? And sometimes that's keeping up with like vulnerabilities in the supply chain. Like there's a bunch of fun stuff going on with certain libraries in Kubernetes right now. Are you keeping up with this, or are you completely blind to it unless somebody, you know, a client or a customer calls your line and says, "Hey, what are you doing about this?" Log4j might be another example. Different things, different types of attacks, different vulnerabilities and such that will pop up. Are you keeping up with what's going on there?
Okay, that's quite insightful there. Bart, do you want to add anything to that?
Maybe just two things from mine to add to this very complete explanation already by Brian. So I think for if you look at architecture, it's a white hat and black hat perspective. So architecture validation, you're typically more coming in from a requirements perspective, and you're indeed validating that the architecture meets the requirements. You're looking at controls that meet the requirements. Architecture mitigation is more coming in from a threat perspective rather than a requirements perspective. So how can it go wrong? And am I sufficiently protected against this? Now, why do we need this activity? I think one of the reasons, as Brian mentioned, is it changes over time, and you still want to make sure that your solution is properly protected. A second element to me, and that's also something that I want to add, is well, if you can build a system and hope that the system is okay if you have, for instance, a complete set of requirements or a complete set of threats. But what happens if you did not do requirements engineering properly and you have very incomplete security requirements? Then you can just not rely on the fact that your system will be protected sufficiently because half of the requirements are not there. So this activity is also there to make sure that even without a proper analysis up front, that you do a second thought analysis around what have we built and is this really sufficient in terms of security to meet typical controls, good practices that you would expect, or meet common or important threats that you want to defend against. That's for me a second reason why this activity is there, and it's actually an important complement to other activities that are in the model.
Mm-hmm. Okay, but let's try to make this as practical as possible. So, say we're building a simple web shop, has integrations with third-party payment providers. Could you walk us through one example of a particular aspect of architecture, so validating that architecture for that web shop, and another example of an architecture mitigation for that specific system?
Yeah, maybe I can start off, and Brian, please complement where you see fit. I think it depends on the level where you are in, but from a maturity level 1 perspective, architecture validation would be thinking about, okay, how if I have a web shop, I probably need some authentication to be in place. You want to make sure that depending on your authentication, you have access to particular data for yourself, but not data for some other user on the system. You might want to make sure that some data is I don't know, your password is not stored in plain text in the system, so on and so forth. These are typical controls that you would expect. So at the maturity level 1, you would be thinking about typical general controls around, okay, did we think about authentication and is it in there? Is it in the system? Did we think about authorization and what's our authorization model? Is it okay? Is it good enough for the system that we're building? What about secure transfer? Typical controls, secure connections, typical controls that you would expect on an architecture. And there's in the model, there's a number of examples there that are typical basic controls that you would expect in an architecture. That's from a quite a basic level perspective that you would do validation. If you're building that web shop, actually the architecture of the web shop is probably a bit more complex because you would have a front end, a back end, there might be a database, there might be some integrations going on. If you're going to a level 2 in the model, the architecture validation goes into a bit more rigor into how do you do this validation of the controls. Let me give an example. Authentication, there's probably user authentication going on, but the backend of the application will have to authenticate, for instance, to your database. The integrations will have to authenticate with the backend, so on and so forth. So also there's are all sorts of authentication going on. So rather than thinking about, did we think about authentication at the first level, maturity level, level 2 goes in a bit more rigor and thinks about, okay, what are all the different components in my solution and how do they all perform authentication? And is it really a sound model? Is it maybe not the case that there is some user level authentication in the front end, but all the rest is system level authentication, and maybe that's not good enough. Maybe you want to have more user information propagated through authentication through your model. So thinking more rigorously about, okay, what's the structure of the different controls for every component in your solution, that's going to a second level validation activity. So at the second level, you're doing it more rigorously, component per component, thinking about all the controls and all the requirements that you want to implement in your architecture. Same reasoning holds a bit for the mitigation. For mitigation at the basic level, you're thinking about, okay, what are some of the threats? What are some of the common threats that I can think of? And are they properly mitigated in the architecture? Brian gave some examples about supply chain, or maybe some denial of service, or maybe some leaking of credentials that's going on. How can we protect against that? At the second level in the model, you're again doing this more rigorously, which normally means that you would have a more extensive threat model as an input, and that for this threat model, you would actually go for all the different components in the architecture and the different threats that you have identified. Is this really properly mitigated in a more structural way? So first level of this activity is always more, let's say, ad hoc, with reasoning about common scenarios, common requirements, common threats. Second level is on more structured, more in-depth way of doing it, and also definitely looking at the architecture in more detail, component per component, interface per interface. That would be my take on how this would happen in practice.
Yeah, and building on like what Bart's examples that he was saying, like one example I can think of for architecture validation is it may be when you built this, you have your integration with your payment provider, you decided for better or worse that SHA-1 was a perfectly fine hashing algorithm. So you check the box, you hashed credit card numbers, you hashed passwords, whatever, SHA-1, it was great. A couple of years later, you find out that's probably not the best of ideas. And so, but if you never go back and look, right, you've got your box checked, you're like, hey, I'm hashing everything, it's all good. And you have risk that you're not really paying attention to, that you're not looking at. And so sometimes the technology changes, sometimes, access controls. I mean, we used to think shopping cart apps with just your email address was enough. I mean, you didn't even need accounts with passwords. Everything was fine. And so it's been a progression over time where things have to get harder and harder to do. Because fraud and theft and, there's a lot of fun things out there for people to play with. So it may be that you put a control in place, but over time that control weakens. I mean, you look at the GPU processing and you can offline brute force of passwords now is absolutely ridiculously powerful. And so, you may not have hashed passwords well enough when you started and you need to migrate that. Architecture mitigation, it may be that your payment provider you thought was great, their sales and marketing people sold you on it, and then over time you found that their security practices aren't that great. You have questions about integrations, you have all sorts of things that leave you open to more risk. And it's not just like industry, global, different threat actors. It may be the companies that you have contracted with that are creating this risk. But to me, that's like in the scope for the mitigation. Like I need to consider all the different risks that are present in my architecture. Am I properly handling those? And it may be I need to change out a type of control. I might need to go from, well, this is probably validation, but I might need to go from role-based access control to attribute-based access control because I found out with my user base and the requirements for how we want to do access control, we keep creating too many gotchas and weird things in my role-based access control, and attribute-based would solve that. But it's that act of going back. It's just an interesting challenge. And well, I don't want to jump ahead too much, but if you don't threat model, you typically don't do this part either. So this kind of you kind of have to threat model to go and follow up later, because you wouldn't do this. This isn't something that comes to mind that says, oh, I need to look at the architecture again. And the interesting thing is looking at the architecture is something you dearly need to do because it's one of the most expensive problems to have. So if you have a bug in an implementation as a defect, those are relatively cheap by comparison. If you have a flaw in your design, those can be incredibly expensive. And so, like anytime you go back and you have a chance to go back and revisit your architecture and say, are we doing this well? We have the right things in the right places. I mean, application software development's complicated. Especially when we moved away from waterfall and monoliths, and we have 50 different ways to build what we call an application now, which is a whole nother topic on how you define the term application. But
that's going to be covered in one of our other podcasts there. Okay. Anything else to add, Bart, on this? Okay.
No, not really.
So when this all seems quite logical to me, but how common is it really for organizations to actually do this architecture validation and mitigation activities? Is this something that you see happening a lot, or is this quite uncommon and more for like high maturity organizations? What do you see in practice?
so in general, the benchmark data shows that it's not common at all. Honestly, the architecture assessment as a security activity has the second lowest score in the benchmark data. It's second only to requirements testing, which is a little surprising, but we also have a small sample set at the moment. So that may factor into that a little bit. But like I was alluding to before, if you're not doing the threat modeling or like secure design principles, shared security services, you're not doing the design up front, you're not going to be doing this. So it's interesting that I've seen over the past several years since we released 2.0, if you're not doing that part of the design business function in terms of the architecture and thinking about it there, you're really not doing it in architecture assessment. And so it's interesting because even level 1 of architecture assessment is not really the same as level 1 in a lot of the other areas. It's kind of stacked on top of getting to level 1 or 2 of another area. And so generally, I don't see that. And that's something that I'm playing with over the summer as I want to go through and look at some metrics within benchmark between each other. Because I want to see, likelihood of if I'm threat modeling or I have a certain level of threat modeling, what am I doing in other areas? Or vice versa. Like, what are relationships between what people are doing? So the highest rank. So of the 90 questions within SAMM, the highest rank is 35th. And that's do you review the application architecture for key security objectives on an ad hoc basis? That's stream A, level 1, very basic. That is the average score on that is ranked 35th out of 90. If you go to the level 3s, you're looking at 72nd and 87th out of 90. So that's much less common.
All right.
Yeah. Let me add some other elements. I think that, in my opinion, the architecture validation and mitigation is typically practiced initially when you're building a system once. So when you're designing a system, and especially if the system is rather new, let's put it that way, you're thinking about, okay, what should the architecture look like, and what are the security mechanisms that we should put in there? Maybe some limited threat modeling, thinking about threats. At that point in time, typically organizations, from my experience, quite often are thinking about this. Now that's before you start building, and then the build starts. You typically then have to deviate here and there from things, and then over time, again, the system deviates, the context deviates, the context changes, your organization changes. These are all elements that require you to revisit what you've been doing. And there, it's also my experience that, and we in professional work, we provide quite some advice on software solutions to organizations. And my experience is that quite often, when we have to look into an architecture to do exactly this validation and mitigation, quite often the view of what is the current state of the architecture is even not there, often not there. So in my opinion, the maturity, what Brian was mentioning, is also linked to how mature is your architecture practice in the organization? How mature is it in maintaining, keeping, following up the architecture of your solutions and regularly revisiting what is there? Again, doing it once before build, that's one thing. Keeping a continuous eye on how things evolve and whether we should change, that's another thing. And the second element is often where organizations, in my opinion, don't always find the time or don't want to invest really their efforts and choose to invest it in other activities or in building features or whatever the choice is, but less so in the continuous validation and mitigation, or the regular, I would say regular, not continuous, but the regular validation and mitigation. Yeah, that would be my 2 cents on that.
Well, and Aram has an interesting question in chat asking, where do we draw the line between architecture and code? And it's and even taking a step back from that is like, how do you define architecture. So one of the projects I've been working on related to trying to assess election technology over the last 4 or 5 years, we actually have two types of architecture in that assessment. We have a system level architecture, which is like all of the infrastructure. It is where your app lives, who does it talk to, is it serverless, is it on virtual machines, like everything that it lives on. And then there's software architecture, which is all of the components, the libraries, the design, the patterns and frameworks within the application itself. And so when you look at like where do we draw this line, it's fascinating to me because again, software development's stupidly complex. But from my interpretation, architecture is the intent, right? So it's the design, it is everything outside of code. Yes, we can describe, we have infrastructure as code, we have all sorts of things as code. For me, the design is what is my intent with this application? Like, how should it operate? Not necessarily how it does operate, that's implementation. But for me, architecture is everything that's pre-code. It's the requirements, it's the diagrams, it's the more of the human side in terms of trying to make everything work together.
Okay. All right.
Maybe,
Bart, yeah.
Yeah. To me, architecture is just an abstraction of the code. And what level of abstraction that is, there is no right level of abstraction. It's the level that makes you understand how this works. And that to me is architecture, but it's not at the level of code, it's an abstraction. And it can be, for a web shop, it can be 2 boxes on a piece of paper with a line between, or 3 boxes. But probably that's, or maybe that's not enough to understand how it really works. And then you probably have to go 1 level down in abstraction and add some more information to it till you understand how it works, but not on a code level. That to me is architecture. And there is no single perfect level of abstraction to it. It's just a level where you can understand how it works, but not at the code, not at the level of code.
Makes me think about the saying that all models are wrong, some are useful.
Yeah,
anyway,
exactly.
It's let's try to wrap this up because the podcast we try to keep them a little bit short because we can probably go on for a couple of hours here. I really like, so imagine we're an organization, we've just listened to this podcast, say, okay, let's maybe you should be doing this architecture assessment thing. How would you recommend to start off this practice? Who would be doing this? And very practical, but what's a very practical advice to kickstart this activity?
That's a good question, Seba. Let's let's try to answer. Let's try to answer that. I think one of the prerequisites for this is to make sure that you at least have a view on an architecture of a system, right? So one way or another, you should have some way that describes how this solution works. Whether that's a diagram, whether that's there can be different forms. Quite often it's diagrams, but not necessarily the case. But you need some way to describe how the solution is supposed to work. That's the first prerequisite to me. If that is not the case, then the activity is probably going to be difficult. There are solutions out there that can build architectural views from code, and that's probably not a bad idea. But whether you look into these tools or build it yourself, as long as it's an accurate representation of how this thing works, that's a good starting point. When you want to do the analysis, a good way to get started, in my opinion, is to put somebody with an architectural view on the system together with a security savvy person to reason about this. And to just say, okay, how does this thing work? What would we typically expect in terms of requirements, security features, threats, and let's discuss how the application protects against this. What's there? And it doesn't have to be a lot more than that as a starting point. Just having the architectural view and security view combined in some kind of a workshop as a starting point is how you can get started. Now, of course, things change over time, so it's not a one-off activity. Probably you want to organize this regularly, and what regularly is, that can be an entire debate. But I suppose we could say, let's say maybe once a year or so is probably not a bad timing to get this done. But it might depend on your context. It might have to go sooner or maybe less if the system doesn't change a lot or the context doesn't change a lot. But it's not a one-off activity. From time to time, you want to do this exercise. And that, in my opinion, is a quite pragmatic way of getting things started, and move up the ladder. Because once you've done this a couple of times for different applications, or for one application several times, you will get the hang of it. You will also understand a bit more, okay, what are typical things that we have to pay attention for? How can we maybe organize it a bit better? Maybe should we look for a way to formalize this a bit more? But that's a second step. As a first step, just starting to talk about it, that's, in my opinion, the best way to get started.
All right. Yeah, that's great advice. Brian.
So yeah, similar to that. I mean, like I mentioned before, you need some element of threat modeling, but generally it comes down to that same core that Bart was talking about. You need a common understanding of what the system's intended to do. And most of the time, a diagram helps with that. And it may be you have a whiteboard session and you just start drawing. You're like, this is what I think it is. I've found it's also super helpful to have whoever, I mean, it might be a tech lead, it might be an architect. It's really hard to give role names because given 100 companies, there's probably 40 different role names that take on that responsibility. But it's the person who's like in charge of the overall design or tech lead, dev lead, whoever. So some architect type role, some security type role, but also I like to add a business analyst or somebody who's responsible for that translation between what the customers or the clients or whoever the users or consumers of the system are, and them having to create requirements. Because even if they can't contribute like a whole lot in these sessions, they learn an enormous amount. They also learn like limitations in the way to think, a different way of thinking about the system, so that when they're collecting requirements and they're trying to figure out, okay, what do we want to do? How do we explain this to people? They understand the terminology better, and they also understand limitations of systems. And so in my experience, the most successful times I've had is when those three roles are together. It's always beneficial to have QA and some other folks as well, but those at a core three roles where you have the intersection of architecture, design, security, and the business, then they all learn from each other. And that gives you the best chance of understanding, are we doing this well? Because we also have the problem of making sure security is not being done to the detriment of other things. And so it has to find its place. It has to be a balance. When to do it, like Bart said, it is highly subjective. If you release every 30 days, you might want to do it more often. If you release every 2 years, you may not need to do it as often. There's a cadence, and it really depends on how much change happens, release cycles, what type of industry you're in. You might be in an industry that very little changes over time. You might be in one that's ridiculously hot, hopping and changing dramatically. So that's why we can't give you a silver bullet and say, here's your template, 2-page Word document, and you're good to go. That's why this is hard. But I mean, you have to be able to assess. There is hope. It's SAMM. You at least have a way
Absolutely.
to start describing what you're trying to do, which is one of the hardest things in software development, is to figure out, where am I? That map that says you are here, and then figure out where to go. Like, what path do I take? It's 360 degrees of movement. Like, which way do I go?
Mhm. All right. Well, thank you very much. And I'm going to wrap it up here. Brian Glass, thanks for your input. Bart de Win as well. Adam, for kicking this off. If you're looking at this on YouTube, make sure to hit that subscribe button if you want to join on our upcoming podcast live. We have a community call every second Wednesday of the month. And the best way to join us is to actually go to oaspsam.org. Go to the meetup link and join the meetup community, and then you'll get notifications and invitations for these podcasts and the community calls. So thank you for listening, and talk to you soon.